Video 7, Git Workflow 2.0, Debugging and Organizing Larger Group Projects. In this video, I'll show you some tools that will help you debug thousands of lines of code and compare them with each other before you experience merge conflicts, as well as a workflow model that will speed up your development process. So at this point, you're already familiar with forking a repository, cloning it down, making changes, and then sending a pull request. And this works and functions. However, when you have multiple developers working on the same team, this gets tedious. Likewise, with all the pull requests being submitted, you have to wait for sometimes hours or even days before your pull requests are accepted before you can continue development. And there's a more efficient way to go about this. Inside of your repository tab, there's your settings menu, and then there's your collaborators sidebar. Inside of here, you can search for people by username and add them as collaborators to your repository. And what this does, this will allow everyone direct access to the repository where they can push changes and have them go live immediately. And this saves a lot of time as there were no pull requests to deal with. However, it comes with its own downsides. The downsides being that everyone has access to the same files at the same time. This can, obviously, be a major source of merge conflicts. There's a way to get around this. Just like you can branch on your local machine, you can branch on GitHub itself. And I'll give you a quick example of what that looks like. You can see multiple branches on the same GitHub project. Except that when there are changes between them, and you want to combine them all to create your final release, you need to find a way to do that. And when you're looking over thousands of lines of code, this gets tedious. So I'm going to show you a quicker, more efficient way to do that. On our repository, we only have one branch. And here's our local machine. If I run git branch, you can see we have 3 branches available: correct branch, master, and typo branch. Obviously, typo branch creates typos for the sake of this exercise. So I'll be getting rid of that one in a second. We have 3 branches on our local machine, but our GitHub only has 1. Let's say we have changes that we want to push up there so that they're available for other developers to continue working on. You can run that by running git push origin, which is the name of your repository, and then the name of the branch, which in this case is typo branch. If one does not exist on GitHub, Git will create it for you automatically. And there it is. But that's our typo branch, which has problems, and we don't actually want to send up bad code to other developers. You can delete this just as easily by running git push origin -- delete and then the branch name, and this will automatically delete it from your terminal. And now, just like that, we are back to 1 branch on our repository. Obviously, it still exists on your local machine, so you can push it back up if needed. Once again, when dealing with branches on the remote repository, make absolutely certain you no longer need them before you decide to delete them. Here's our correct branch. You can see I've made some changes since our previous exercise. There have been some dots added. I've also finally fixed a typo on H5. And yet our typo branch still possesses these errors. Running git diff, I can compare the difference between them. I'm running correct branch, .. and then the typo branch. And what this does is inside your terminal, it'll show you the differences. You can see the H1 and the H2 tags are exactly the same. And here's our correct branch, the H3, H4, H5, right there. And here's the H3, H4, and H5 of the typo branch. Obviously, attempting to merge these would throw a merge error. And this will give you an example of what it looks like and what the differences are between the branches before you ever go into creating merge conflicts, allowing for a much smoother transition. And when you have thousands of lines of code and are trying to find one code difference, this automated process will save you a lot of time. Now there's another option to this. Using 3 dots instead of 2, you can compare both branches against their parent or ancestor branch, assuming that both of these branches have the same parent. Likewise, you can also, at the end of your diff, just put an output. I'm going to call this log.txt, and this will create a log file with all of those changes like you saw earlier. Here it is in Sublime Text Editor. And the great thing with this is you can send this file to someone if you need to compare changes, or you need to simply propose changes, or simply have one for your records, as opposed to just viewing it in the terminal. But we don't actually need this log file, so I'll delete that real quick. Likewise, git diff also works on a single branch. You can see right now we have nothing to commit, and our directory is clean. But let's say last night you were working and made some changes that you aren't sure about, or simply forgot to commit. So there's our change, and I've saved it. If I run git status now, you can see we have modified changes. but you log back in the next day and have no idea what the modified changes are. Running git diff head in a reference to your last commit allows you to compare changes inside of your terminal the same way. And you can see right here, we have our 2 additions that we don't need. This way you can check exactly what the changes are between the commit you're about to push and your previous commit to make sure that you want all the changes you've made. But we don't need that, so let's get rid of that real quick. And that's how you use git diff to debug thousands of lines of code. Obviously, this is a scaled down example. Another tool I want to introduce you to is the use of the git rebase command. And this has a lot of use cases and a lot of functionality, a lot of which is beyond the scope of this video. And when it comes to the git rebase, I've known developers who use it daily. I've also known developers who have been developing for years who have never used rebase in their life. When all else fails, or if you have questions, contact your senior developer. I'm going to go ahead and give you a quick demonstration of how this works though, in a very basic example. If I run a git log real quick, you can see we just have same h1, h2 as our last commit. Let's make some changes. This is going to get tedious for a second. If I run a git log now, you can see we have 3 commits, and they've all done very, very little. Let's say we want our code to look neater, and we don't want thousands and thousands of commits. You can run git rebase -i head, which is your last commit, and decide we want to go back 3 commits from there. And this will open Vim, which is the default text editor of MacBook and any Mac OS system. If you're using Windows or Linux, you may have something else. But I'm on a Mac, so I'll give you a quick demonstration of how this works. Press I to go into insert mode. Right now you see all 3 commits are set as pick, which has them set their own commits. You also have other options as listed below: reword, edit, squash, etc. You can look over those in your own time. I'm going to go ahead and squash these down. This keeps the changes. However, it combines them into a single commit. Once you're done with it, just press escape to exit insert mode. Do semicolon W to write your changes, and semicolon Q to quit out of this. And you can see your commands here. It'll just say that this is what's going to happen. It gives you commit 1, commit 2, commit 3, and it's going to combine them. Once you're done, you can simply quit out of this. Successfully rebase and updated refs head correct branch. So if I go to git log now, you'll see that we only have 1 commit that has all 3 of our messages and all 3 of our changes. And this is a nice way to cut down on the total amount of commits you have, to make your code and code history much easier to read and parse through. In the next video, I'll be going over logging your changes and writing documentation for them that isn't commit 1, commit 2, and commit 3. I'll see you in the next video.